Hey, what's up, guys? I just wanted to show you that you can solve the Black-Scholes equation with quantum mechanics. So what you first have to do is transform his PDE, right, into these new coordinate systems. So we would say the logarithmic coordinate of price, right, because price can't be negative, etc. It's all logical, right? And then we're also going to use the time to maturity coordinates. It's just the time until it matures. It transforms the Black-Scholes into a forward equation. We'll also define this kind of utility kind of function that we're going to do other things, but I'm just showing you that you can get the price of the contract or of the option contract specifically from this new function. You then would get an expression such as this, but we're going to try to let this utility kind of function that we're using, we're going to try to pick out some parameters A and B, or sorry, alpha and beta. These would be gauge parameters. And we're going to do a gauge transformation of some, psi, okay? And then you're going to need to choose alpha such that it'll eliminate this first order term, okay? And then you're also going to need to get beta in terms of alpha and eliminate the zeroth order terms to then arrive at the heat equation with the diffusion of 1/2 times the variance. This is pretty standard stuff. And this isn't necessarily the easiest thing to do, but once you do it, it's kind of satisfying because everything cancels out, and then you get the heat equation, all right, with the diffusion coefficient and such. Okay, we can go a step further. So let's assume that we can separate the time to maturity and the spatial coordinates, okay? And when we assume this, we can then derive at this guy here, okay? And this guy is the stationary Schrodinger equation from quantum mechanics. And it turns out we would find out that we get a financial Hamiltonian for a free particle, question mark, with the potential equal to 0. Okay, so just ignore kind of your pre-assumptions about physics, right? Just think of this as a way to solve it, okay? I mean, technically this would be like 1 over mass, right? Or related to 1/2, or 1 over 2m times momentum operator, but I mean, we have variance. Okay, whatever, right? Let's not worry about that, okay? So from a gauge transformation, from alpha and beta, we can then get the price of the contract is equal to this, right? We plugged in our alpha, beta, and also we have our stationary Schrodinger solution, and this set of eigenfunctions, okay, that would solve this. They happen to be plane waves, okay? And then the plane waves will give you the energy eigenvalues that you can solve then via the Fourier transform, okay? Integrating over all of the frequencies of those plane waves. There you go. And then, you have for European call, your boundary conditions. I'm just showing you that it translates directly into solving it. So, that's how you use the Schrodinger equation to price an options contract. Thank you for watching. Goodbye.